Primary diabetes mellitus regarded as primary process for which individuals have a genetic predisposition and are classified as either type 1 diabetes mellitus, which can be known as insulin-dependent diabetes mellitus or IDDM, or type 2 diabetes mellitus, which can be known as non-insulin dependent diabetes mellitus or NIDDM.
An autoimmune system can attack healthy pancreatic beta cells in Langerhans Islands, which leads into its destruction. Pancreatic beta cells is the site production of the insulin. The destruction process decreases the insulin production, which leads into type 1 diabetes mellitus with insulinopenia condition.
According to the explanation, the phastation process of the beta cells pancreas is needed to induce this type of DM. While in the type 2 diabetes mellitus, the pathophysiology is caused by the insulin resistance. Pancreatic beta cells try to compensate the hyperglycemia condition. By producing more insulin, eventually beta cells function becomes impaired. In purpose to reach that condition, the animal model is fed by high energy diet.
There are several methods used to induce diabetes mellitus in laboratory animals, such as pancreatectomy, alloxan-induced diabetes, streptozotocin-induced diabetes, other diabetogenic compounds, hormone-induced diabetes, insulin deficiency due to insulin antibodies, and virus-induced diabetes. These methods have both advantages and disadvantages. The advantages of pancreatectomy are resembles human type 2 diabetes due to reduced islet beta cell mass, avoids cytotoxic effect of chemical diabetogens on other body organs. 100% of animals achieve DM. And the disadvantages of pancreatectomy are involvement of cumbersome technical and post-operative procedures only for IDDM, occurrence of some other digestive problems, cause problems in the counter-regulatory response to hypoglycemia, mortality is comparatively higher. And then, the advantages of alloxan-induced diabetes are selective loss of pancreatic beta cell, leaving other pancreatic alpha and beta cells intact, may achieve diabetes in 48 hours, comparatively cheaper, affordable, no DNA damage. And the disadvantage of alloxan-induced diabetes are hyperglycemia, insulin deficiency rather than consequence of insulin resistance, less stable and reversible, may produce toxic effect on other body organs.
Streptozotocin-induced diabetes. Advantage: diabetes induced by streptozotocin is more stable. May achieve diabetes in 24 hours. This model can be used for longer experimental study. Disadvantage: comparatively costlier to develop. Other diabetogenic compound. Advantage: comparatively cheaper to develop. Mortality is relatively less. Can be developed in all types of experimental animal. Disadvantage: may affect other organ. Variability of result on development of hyperglycemia is high. Hormone-induced diabetes. Advantage: stable and irritable diabetes can be induced. Ketonuria and ketonemia occurs. Not developed in small laboratory animal. Disadvantage: only effective in adult dogs or cats. comparatively coster to develop, may affect other organ.
So for the next method, we have insulin deficiency due to insulin antibody. In this method, state of insulin deficiency occur and in this transient diabetic syndrome, but this method comparatively costlier to develop, reversible at lower dose and can cause ketomia, ketonuria, glucosuria, and acidosis occur in higher dose. Next, we have virus-induced diabetes. In this method, stable and irreversible diabetes can be induced. This method also comparatively costlier to develop, and it develops type 1 diabetes, and handling of virus require a technical expert. So, of all the method, STZ and alloxan are by far the most frequently used method and has been useful for the study of multiple aspects of the disease. In terms of cost, STZ is more expensive than alloxan, and STZ is less associated with cellular toxicity, and that makes this method lesser animal mortality, while alloxan have higher mortality, less stable, and also reversible. STZ can achieve diabetes in 24 hours, while alloxan takes 48 hours. In conclusion, the STZ method is better and more efficient as a DM-induced method compared to other methods.
Answer number 3 is alloxan-induced diabetes mellitus through ketosis process. Growth mechanism and height rate mortality, whereas streptozotocin through nitro oxide and nitrosative stress, aconitas inhibition, ROS and oxidative stress, DNA alkylation, OGLGNA-case inhibition, inflammatory and cell survival pathway.
According to its mechanism of inducing diabetes mellitus and its properties, generally, streptozotocin is more effective than alloxan. For instance, streptozotocin relatively more stable in aqueous solution with 15 minutes of half time compared with alloxan, which is just 1.5 minutes. In case of inducing hyperglycemia for longer duration, hyperglycemia induced by streptozotocin can last as much as 3 months, better than alloxan, which is less than a month.
Moreover, alloxan causes relatively more damage to beta cell by incidence of ketosis, loss mechanism, and heat rate mortality. Alloxan also can cause damage not only for beta cell but also to the cell which express GLUT2 and cause systemic toxicity with streptozotocin are specific to the GLUT2. Streptozotocin has lesser variation in animal species.